Morning everyone. I hope you all will be fine, safe and healthy at your home, and I hope you all will be enjoying your online classes. So let us start our today's session. As you all know that in the previous session we have studied about the Gibbs energy. So today we will discuss about the some cases of free energy change, means Gibbs energy change, and what are the condition at which the reaction becomes spontaneous. Okay, so now you see here the I have written there Gibbs energy change and the equilibrium. You see here equilibrium when the rate of forward reaction gets equal to rate of forward reaction, backward reaction. So RF is equals to RB, forward, that is equal to backward. So you see here, so delta G of chemical reaction that allows, you see what points I have written. Prediction of the spontaneity of the chemical change. So delta G that gives information about that how the reaction will be spontaneous or non-spontaneous. The second point you have to see, prediction of the useful work that could be extracted from it, and we get the knowledge about the useful work. Okay, now so when the equilibrium is not reached, so we use that equation delta G, that is equal to delta G naught plus RT natural log Q. Delta G naught, this is the standard Gibbs free energy, and delta G, this is the Gibbs energy change. And you all know that I have taught in the previous session, at equilibrium delta G that is equal to 0. So we have to put there in place of delta G what we will write there 0, and for the equilibrium constant in place of Q we write there K. So delta G naught that becomes equals to negative RT natural log K. So whenever the natural log it is to be converted into log, it should be multiplied by 2.303. So here we will multiply with 2.303 and natural log will convert into the log. Okay. So in place of Q we have written there K, and you can write there Kc also. Okay, that denotes the equilibrium constant. So we have got that one relation about the delta G that we can use during the numerical problem to calculate the Gibbs free energy change. So let us discuss about the effect of temperature of reaction for endothermic or exothermic reactions. What will be the effect of temperature on spontaneity of the reaction? Okay, so the first case, as you have to see the points I have written, for endothermic reaction means we have to provide the temperature to the reaction for its spontaneity, means it has to move in the forward direction. So suppose if you will increase the temperature, for endothermics it needs the temperature, so it means we have to provide the temperature. So the condition that comes, higher temperature favors the spontaneity and feasibility of the process, means जितना आप temperature बढ़ाते जाओगे reaction that will move in the forward direction. Okay, but for the exothermic reaction the condition that gets reversed, because exothermic reaction that releases heat energy. So whenever the heat energy it is to be releases, so delta H is to be negative. Okay, and T delta S would be negative also. So it in terms of low temperature, because high amount of heat energy is already releasing, so we cannot increase the temperature. So low temperature favors the spontaneity of reaction. So you have to understand, for endothermic reaction high temperature will favors the spontaneity of the reaction, and for exothermic reaction low temperature will favors the spontaneity of the reaction. Okay, so here I have made one chart where you can see all the condition, because I have taught enthalpy change, entropy change, Gibbs energy change, and this equation I also have taught, and here I have written all these condition when the reaction will be spontaneous and non-spontaneous. So all the sign conventions, and at high temperature and the low temperature all conditions I have mentioned, that you have to learn it properly. Okay, so let us discuss the one numerical problem that is based on the Gibbs energy change. So now the question which I have brought to you that you have to solve, calculate delta G for the conversion of oxygen 2 ozone. So 3 by 2 moles of oxygen, 2 to 2 will be cancelled, then O3, that ozone we will get it at 298 Kelvin. If Kp for this conversion is 2.47 into 10 raised to the power negative 29. So here you can use this equation, delta G is equals to negative 2.303 RT log K. So Kp is given, so we can write there Kp. Okay. So now all these values you have to put there. 2.303. The value of R will be 8.314. Temperature it is to be given 298, and the Kp it is to be given 2.47 into 10 raised to the power negative 29. After multiplying all these values, you will get the value of Gibbs energy change. So this is the way how to solve the questions based on this equation. I hope you all have got it. What is the Gibbs energy change and what are the specific conditions for the sign convention for the spontaneity of the reaction. That's all for today's session.